So just let me say, I was hoping all the other speakers would go way over time so I could just say to you what Aaron said at lunch, okay, and then get off the stage. But darn it, we're on time. Okay. Thank you all. I'm Victoria Andrews. Changed my name not too long ago. You may remember Victoria Friedensen. That's me. Emails work both ways. It just took NASA a long, long time to admit that I changed my name. So, at any rate, so thank you. I am hoping I'm doing this right. We wanted to present to you an update on our progress on the action plan at the last Planetary Defense Conference in Tokyo. We announced that we had published the strategy and that we were redoing it into a strategy and action plan, and we promised to come back and tell you all about that, and here we are. Why the action plan is important. So as you know, and I know you all know, large and small asteroid impacts have occurred in the past and are going to occur in the future and could be more devastating than those created by nuclear explosives. The action plan represents the first step for the US government to identify and develop possible responses to the hazard. As my colleague L.A. Lewis says, you don't want to be exchanging business cards at the disaster. Okay, so we'll get that started. So possible responses to the hazard may not be easily accomplished or may require long lead development, even with a plan in place. I think one of the things that we were looking at as we worked through the exercise last night and then the other afternoon is that in a possible scenario where you're looking at many launches of critical spacecraft at almost the same time, that this is a complexity that we may not have considered in the past, and it will be something we will need to be able to plan for if necessary. And because the nation's engineered environment is much more extensive, not the nation's, the global engineered environment is much more extensive and much more fragile than I think we realized. As you know, the graphic on the left is the global fireballs reported by US sensors since 1988 up until 2009. But the other photo is from a film called Welcome to the Anthropocene, in which you've heard various epochs, geological epochs in the development of the Earth, the Pleistocene, et cetera, in which the idea is that humanity is changing, actively changing, not only the surface of the Earth, but Earth's processes. And when you look at these night images, you see that there's very little spare land to let an asteroid just strike, right? There's no send it to that place, nobody will care, probably does not exist. And that's why the action plan is important. Our colleague Ben Corbin at Stippy developed this graphic a few years ago. Ben, are you here? You were here earlier today. At any rate, and I think it really illustrates why the action plan is important and also why we are doing what we're doing here at this conference today. So it's not just about finding them and tracking them or developing space missions, okay, or talking about it or planning for it, but it's a continuous process in which modeling, decision-making, international cooperation, and communications and coordinations have to go on and keep going on, if for no other reason that there's a group of people who will continually be aware of and knowledgeable about this potential hazard, even if you are or are not working an active threat. So even if we have decades to know about it, years to know about it, a few days to know about it, or hours to know about it, there's a group of people also that have been thinking about it for a very long time to come. And hopefully we'll avoid that big yellow ball there, and as we said earlier today, so that FEMA won't have to go into action. As you know, the action plan, as Aaron so eloquently discussed it during lunch today, was released last year. And what I want to do is just go down through them. There's 32 actions in the plan. I won't go into all of them because of several we haven't actually started yet, but just to give you a quick update. So on the first goal, to enhance our NEO detection, characterization, and tracking capabilities for the U.S. So identify opportunities for existing and planned telescope programs to improve their detection and tracking capabilities and their characterization capabilities. So we're looking at this. PDCO is assessing the planned and potential improvements for existing observatories and potential observatories so that we can continue, as you heard on the first day, when there have been improvements and there are planned improvements in the nation's capability. On the second one, goal to improve modeling, prediction, and information integration. So as Aaron spoke about, he mentioned an interagency working group. Well, we've got one in place already that is established by the Asteroid Threat Assessment Project, ATAP. You heard several talks today and yesterday led by Donovan Matthias. And the working group has been established, and they're coordinating plans for technical interchange meetings, white papers, et cetera, and working with other response aspects of the U.S. government. We work very closely with the Department of Energy and with the Department of Homeland Security. The third, to develop technologies for deflection and disruption. Well, you're seeing a lot of that, okay? There's DART. We had an excellent day with DART yesterday. That is NASA's first funded mission to take a look at that. And then we've also got a working group being formed to look at the idea of designing a reconnaissance mission. What is the de minimis set of measurements that you need to get that essential data? We don't need to know everything about the asteroid, but what sensors, what measurements are they? Do those sensors exist? What would that spacecraft look like? And can we design it to a point where we felt confident that we could rapidly develop it and deploy it? And I am not talking about having something on the mythical shelf, okay? So we're looking at that for reconnaissance missions, and then of course for deflection and disruption missions. Fourth, to increase international cooperation. Here at this Planetary Defense Conference, as well as all the Planetary Defense Conferences since 2013, we include this international exercise. Exercises have been also conducted by our partners ESA and by other agencies that are considering more. We're also looking at conducting exercises domestically in the US. We've been doing these with FEMA, and we plan on expanding some of those to address specific aspects. One of the things that this particular exercise has brought to mind: what if you rapidly needed to build a handful of launch vehicles and spacecraft really rapidly? How would you go about doing that? What would the actual provision of I'm thinking down to the component level. What's the inventory? How do you get them? And how fast can you build, for example, rad-hardened parts? Okay, so these are some of the things that we're looking at or preparing to look at. And then finally, establish neo-impact emergency procedures and protocols, as you heard today, that we are going to set up an interagency working group proposed to review and make recommendations to the Planetary Impact Emergency Response Working Group, co-chaired by FEMA and NASA. I'm honored to be the NASA co-chair, and L.A. Lewis is the FEMA co-chair. And then, as you saw, there was a coordinated international voluntary campaign to observe 2012 TC4, which was enormously productive and illustrated how the various observatories and entities worldwide were interested in contributing to and making a difference in being able to track an asteroid that is of a concern. We're looking at revisiting and validating the current notification protocol chain of command. Boy, that's based on the response to Congress, the original memo from OSTP in 2010, just to make sure that we have the right organizations, the offices, if you will, that get called. There is a NASA-centered requirement for who to call and how we get to make that call in the event of potential impact. And we know that other entities will pick up the phone when we call, and then we just need to refine it from there. So that's my very quick summary of the things that we're doing. The papers and the presentations and the work that you have been doing and the time that you've been taking are all feeding into this effort. In the report that comes out of the workshop, in your recommendations, in the consensus that we get, we'll be blending those into our path forward. So the things that you're saying and what we learned from the exercise that we're conducting with you this week will feed into how we are approaching. So I have to say, on behalf of my colleagues at the Planetary Defense Coordination Office, thank you very much for that. And I will take any questions you have. Thank you.
So how much of this stuff is actually being coordinated with allies as well? Like you talked about, how many can we build? How many can we procure? Is there like, maybe try to get like commitments and stuff in place so it's more of just a United States focused document?
So we're starting. Okay, so NASA, as you know, works closely with the small space missions planning and advisory group, same page, to look at those kinds of questions. Also in addressing the actions in the action plan, we do work closely with the Department of State. And so state are the ones that have the connections to and the communication paths, if you will, back into other nations that may be interested in participating. I would have to say that the international part is probably the one. We have I1 on the same page, but we do have a lot more work to go with state. Yes.
Yeah, you mentioned the design study for a rapid, quick turn, rapid response reconnaissance mission. Is there a plan to eventually actually have some hardware on the shelf, kind of a generic, flyby probe that could just be put on the next available suitable launcher? Just for a kind of
this is a beer conversation, because there are several different camps. There's the sure, put it on the shelf, and then there's the folks who have taken things off shelves and found they didn't work anymore, right? So it's a case of how advanced can we get in terms of actually building a device, right? The components, or do we purposely and consciously select components that are common and easily obtainable? And what's the blend between the two? So it's not a yes or no answer.
Okay, thank you.
Thank you. What else? Do we have? Oh.
DART is in phase C, yes?
Is it?
Yes.
I thought you hadn't gone to C yet.
Oh, we have.
I beg your pardon. I am so sorry. I will amend my slides. Thank you. Thank you.